So hello everyone, I am back with another video. In the previous class I have discussed about the centrifugal pump and their types and what are the advantages, right? I hope you have watched earlier video. So in the previous class we have discussed about the what is the difference between the duplex pump and the triplex pump, and where we are going to use duplex pump and the triplex pump. In this class I'm going to discuss about the working principle of single acting pump, or why it is called single acting pump, right? So yeah, in this case if you are able to see your this is the one cylinder, right? And this thing is called piston. This circular disc having some length is called piston, right? And this is the piston rod. Okay, in a so when this piston at this position I'm talking about here, so when they are moving backward, so what will happen there, due to the difference in pressure created between the, here it is atmospheric pressure is there and here it is vacuum pressure is created. So the due to the pressure difference, the fluid start entering inside the cylinder, and over the period of time it's continuously going backward. The piston is going backward, and all the fluid will cover this piston cylinder volume, right? And then once it's reached at this point, once the piston reach at this particular point, uh, as I told you, this is, you can say, bottom dead center or top dead center, or top dead center and bottom dead center. It's cover some length, right? ls, this having a length of the piston, right? So when the piston has reached at this particular point, this point I am talking about, during the backward motion, now he is doing forward motion. So at that time there is a valve kind of things, that valve is going to closed, and the fluid is going to discharge, right? Discharge over here. So this process is continuously going on, right? And this is the dia of the piston. This is how its single acting pump is designed and their working principle. So P1 is the suction pressure over here. At this point P1 is the suction pressure, P2 is the discharge pressure, and DL is the piston diameter. This diameter they are talking about, right? And this is the stroke length. So if someone is going to ask the question, in a one stroke how much amount of the fluid this piston is going to discharge, or this cylinder or this centrifugal pump is going to discharge, so how you are going to calculate this thing? This is the very simple mathematics over here. We will derive the formula also, so never worry about it. So it will this piston is going to discharge the volume of this piston. So how we are going to calculate the volume? We are going to calculate pi by 4 d square. This is the area, cross sectional area of this cylinder, and if you are going to multiply with the length, this will give you the volume. Means in the one stroke they are going to discharge this much amount of volume, but this process is going continuously. What does it mean continuously? Means there is n times is going on, right? So if you multiply with the n times, we will get, I will derive this expression also, we will get the, in a per second, means the discharge is nothing but the meter cube per second, and this volume is meter cube, right? If you remember the unit of the volume is the meter cube, or this n is the rpm or rpm, revolution per minute. So this will give you the discharge. Okay, this is how you can calculate the amount of the volume you are going to obtain during the suction or discharge during the delivery process when they are discharging, right? This will help you to calculate this formula is going to help you while solving the problem. Now let's move to the next slide, what it is. So in the next slide so okay, the next slide, yeah, this is what we want to understand. So single acting, and it is also called triplex pump. Why it is called triplex pump? Just assume that the single acting means there is a one suction, one discharge. Remember this thing, there is a one suction, one discharge. And when they are adding triplex is the number of cylinder. So as I told you, this is the one piston is there, another piston is there, another piston. So 1 2 3, there are 3 cylinder arranged, and this cylinder arranged in the parallel in the form of parallel. So my question is that why we required a 3 cylinder? Why we required a 3 cylinder if you have already having 1 cylinder or 2 cylinder? What is the purpose of using a 3 cylinder? So the purpose of using a 3 cylinder is if we required a more discharge, right? If you in a one cylinder, if you want to talk about in one cylinder, let's suppose I am assuming that the volume of one cylinder is pi by 4 d square L. So let's suppose this is 10 liter. Let's suppose this is the mathematical way to understand. Let's suppose this is the 10 liter. In a one cylinder they are going to discharge per second this much amount of the volume, but we required a more volume. So we add another cylinder, same formula, 10 liter they will discharge, we will add another cylinder 10 liter. So in a one stock you are able to obtain a 10 liter of volume in the second in a one cylinder. But if you have a 3 cylinder, now you are able to obtain the 30 liter or meter cube of a volume, right? Are you able to understand? So discharge volume is increased. That is why we have adding a 3 cylinder, right? And what is the purpose of using a triplex pump instead of duplex pump? Because I will talk about in the case of advantage. So this is the arrangement. These are the piston are arranged in the parallel way. This is the parallel arrangement, right? And this is not the series. If I have to arrange the series, then there will be one piston, then there will be another piston, then there will be the another piston. But this cylinder is arranged in the parallel way. So why it is arranged in parallel way? We required a certain amount of the volume to discharge, right? So here it is written over here, the single acting plunger arranged 120° apart to deliver a smooth and continuous flow. Remember this thing. So this all cylinder they are apart from 120°, right? This is the arrangement 120°, right? If you want to see the isometric view of a triplex pump, you can add, as you can see that this is the isometric view. And this section, basically this section represent the suction, discharge, and so this is representing the discharge, this is representing the suction, this is representing the transition zone. So this is how the piston working principle of the single acting pump is here, right? Now if you talk about the P1 is the suction pressure, P2 is the discharge pressure, we have already know that. and theta is the angular space between the plunger, right? The advantage, if you talk about the advantage, a smooth and nearly non fluctuating flow. So this is the most important thing that we need to understand, that when we want to the continuous discharge of the fluid, in that particular case we are going to use triplex pump, right? Because of smooth and nearly non fluctuating flow. Like, and the next thing is uniform load on the crank. Uniform load of the on the crank, we have I have told you that the crank is arranged in this case, right? So everywhere the load of the crank on the uniform, reduction in the vibration, and the higher pump efficiency and the reliability. This is the best part about the single acting pump. So remember this thing, the single acting pump, when we talk about the single acting, means there is a one suction, one discharge, and single act, when they are included triplex, means that there are 3 cylinder. So if I have to calculate the volume is pi by 4 d square and into L. So this is the volume of one cylinder. If we are going to use 3 cylinder, we simply multiply with the 3, right? We are going to learn this thing in the derivation part, so don't worry about it. This is how the arrangement of the single acting pump is here, right? Let's move to the next slide. We discuss little bit about the duplex pump. So before coming to this graph, we need to understand this thing, right? We need to understand. So if you observe carefully, there is a one suction is here, there is a one suction is here, there is a one discharge is there, there is another discharge is there, right? And the arrangement in this piston cylinder device are same, right? Arrangement in the piston cylinder device and the working principle of this cylinder is same as previous one. So what are the different thing are there, right? Earlier case there is a one suction, one discharge, but in this case there is a two suction, two discharge. That is why they known as a duplex pump, right? Double acting. Remember that double acting means two suction, two discharge. When they are saying duplex, that means this is the one piston is there. Earlier was in the one piston there are one suction, one discharge, but in this case there is a one piston cylinder device, there is a two suction, two discharge. So don't confuse. If I am talking about the duplex, then we are going to add another cylinder. So once we are able to understand that this part, like when we are going to understand this thing, how they are working principle are of duplex pump. So let's understand without any further ado. Let's understand the duplex pump, how the duplex pump is working over here, right? So for an example, I am right now in this figure that piston is at the center. Let's suppose I am assuming that the piston is at this point. You can assume anywhere, it's up to you, okay? So when piston is, let's suppose any direction I am choosing, right? So let's suppose this is your piston and this is your piston rod. When they are moving backward movement, so they will suck the fluid. At the same time the fluid which is present in this side, it is going to discharge, because they will sweep all the fluids. They will sweep, which is the fluid which is present over here, they will try to sweep. And this valve is closed. The valve which is over here at this point, this valve is closed, right? And all the fluid which is present inside this cylinder, they are going to discharge through this point. Means the cross thing is going on, means this side is suction and this side is discharge. Now this is in the backward movement when the piston is moving backward, but when the piston is moving forward, if I talk about when this direction, when the piston is moving forward, in this case this valve is closed, this valve is closed, and this valve is open, and this valve is also open, and this is closed. So close means like this valve is closed and this valve is closed when the piston is moving forward. So suction is going over here and discharge is going from this way, right? And the other case, when the cylinder is moving backward, in that case when the piston is moving backward, in that case this valve is closed, and this valve is closed, and this valve is open, and this valve is open. This is how the things are there. Now most important thing you need to remember that, let me erase over here the volume. The important thing we are talking about the volume. If you observe carefully the volume, when the piston is moving backward, right, when the piston is moving backward, in that particular case this much amount of the volume you are going to suck, means that this much amount of the volume throughout the cylinder you are going to deliver, discharge, or you can say in here, because the space is over here, the space which is present over here is this much amount of the volume, during the backward motion. I hope you people are able to see and observe. So during the backward motion, but remember this thing, when they are moving forward, means that this direction, they are only able to fill this cylinder up to this much amount of the volume, because this piston rod is over here, it's also occupy here. So the volume in earlier case, let's observe here. In earlier case, if you are observing over here, in the let me color this side, and this side, this is yellow one, right? I hope there is no color blindness. And this side, so when the piston is moving forward direction, they are sucking only this much amount of the volume, this volume and this volume. But when they are moving backward direction, they are able to suck this much amount of the volume, this is how the things are there. So when you are going to calculate the volume, the total volume, the V1, that is forward volume, plus backward when the piston is moving. When the piston is moving forward, so the volume pi by 4 d square minus small d we need to subtract, because this much amount of the volume we are not, and plus L plus something. We will jump into the derivation part, don't worry about it. Okay, so this is how the things are there, right? So we are going to learn about this thing in the derivation part, right? So let's, the P1 is the suction volume, P2 is the discharge volume, DL is the, right, and this dia we are representing DR. Representation is the just nomenclature, you can choose anything if you want, right? DR is the piston of diameter of the rod, LS is the length of the this one, right? During the right word, left to right, the suction pressure is left to right, suction pressure is P1, and right's discharge pressure is the P2. And during the leftward stroke means the right side suction pressure is P1 and the discharge pressure is P2. This is how all about the working principle of single acting pump. In the next class I am going to talk about the derivation and the numerical and and the basic concept how we are going to approach, and the most important thing we are going to talk about the volumetric efficiency, why it is required volumetric efficiency, right? So thank you everyone for watching this video. I hope you people are understand something. Thank you everyone.